So this is second part of video regarding analog multipliers. So this is a symbol of analog multiplier, and we know that it can be constructed using a transistor and with the help of an op-amp. So what is V0? V0 is equal to K into V1 into V2, right? Because we know K value is 1 by 10. Okay, so let us discuss about quadrant. You have a first quadrant, second quadrant, and fourth quadrant. So it quadrant it define the applicability of the circuits of bipolar sign at the input. Okay, so what is first quadrant means? Both the input V1 and V2 is positive. Okay, so it will be in the first quadrant, right? So you can see the V1 value and V2 value is positive. So next second quadrant. So here the second quadrant, one input is unipolar and another one is bipolar. So what does unipolar means? It is positive, and bipolar means it will the swing in both ways, that is in positive and negative. So you can see here V1 is positive, that is it is unipolar, and the V2 value is positive and negative. So it is bipolar. Or I can write V2 is unipolar and V1 is bipolar. That is, V1 is allowed to swing between both the positive and negative. So if in order to make so here you can see V2 is positive, right? V2 is positive, that is unipolar, and V1 is swing between minus and plus, so it is bipolar. Okay, so the next one is about the quadrant. So here so you can see four rectangles there, and both V1 and V2 is allowed to swing between both positive and negative. So it is both are bipolar. Next, let us discuss about logarithm solving technique. The elaborate given definition is already given in the other video, so you refer to that one. So here it is used as a multiplier, and it is limited to the first quadrant only. Because why? Because here both values should be passed. The next one is a variable transconductance multiplier. So this is a circuit diagram of variable transconductance multiplier. So there's something but a simple differential circuit producing the principle of variable transconduction technique multiplied. So here if you see the diagram, I can write from this diagram, I can write V0 is equal to Gm RC VR, right? So this is a relation between V0 and V1. So this is my first equation. So I can write Gm is equal to IE divided by Vt. This is your second equation. Substitute the second equation of first equation, would get V0 is equal to IE RC V1 divided by Vt. That is your third equation. So from the diagram, I can write V2 is equal to IE RE. So from this, I can write IE is equal to V2 divided by RE. This is your fourth equation. So substitute the fourth equation in the third equation, you would get V0 is equal to V2 V1 into RC divided by VT RE. So I can take K is equal to RC divided by VT RE. So K is something what are scaling factors. So therefore, you will get the V0 value is equal to K into V2 V1. Okay. So let us look into the sixth problem. So you can see if an analog multiplier IC provides an output of 3 volt for a 2 input, Vi is equal to V1 is equal to 1.5 volt and V2 is equal to 2 volt. Find the multiplication factor. So this is what they have given. So you know the formula, right? So from this I can write K is equal to V0 divided by V1 V2. So V0 value is 3 divided by 1.5 into 2. So we get answer as K is equal to 1. So in the forthcoming video, we are going to discuss about different types of multipliers. So far we have discussed about the variable transconductance multiplier and logarithmic summing multiplier. In addition to that one, we are going to discuss about emitter coupled transistor type multiplier and Gilbert multiplier. So if you refer the syllabus of the linear integrated circuit, so the first topic is analog multiplier using emitter coupled transistor pair, Gilbert multiplier cell, variable transconductance techniques, and analog multiplier ICs and their applications. So these are the topics which will come under the analog multipliers. Next one is parallel. So parallel means phase lock loop. In that we are going to discuss about the operation basics of PLL, ghost loop analysis, then VCO, and then monolithic PLL, that is IC 565, applications of PLLs for AM detection, FM detection, FSK modulation, demodulation, and frequency synthesizing and clock synchronization. So this is what we are going to study in this unit. So the book to study this topic is you can refer Sullivan and book. So mostly it will cover the entire topic in this unit. So it will be helpful for you to get good score in your university exam. So I hope this video is useful for you. So you can share it with your EEE friends also. Thank you very much.